So in this part of the video, we'll be building our model, right? So this is where we'll be building our machine learning model, okay? Now, to do that, the first thing we have to do is we need to remember that we extracted the numerical and categorical columns. So we actually, for our machine learning building, we actually have to concatenate both the numerical and categorical columns so it becomes one data frame, okay? Now, to do that, we use the method called concat, all right? So let's just say concatenating numerical and categorical data frames, all right? So let's call this df1 is equals to, we use pd.concat, okay? So what are we concatenating? Our num codes, okay? And our cat code, okay? So our cat scores, okay? So this should be add 6 equals to 1, all right? So this should be it. Let's try this and see. Okay, so I think we actually, okay, there is something wrong with this code. So let's put this here, all right? Then let's remove this and let's run this again. Okay, I think that worked. That was, so let's check for results. So we just called df1. So let's run this. Okay, so as you can see, we have successfully concatenated our numerical and categorical columns. Okay, so let's just say print df1 instead. Sorry, let's just say df1 dot head. Let's run this. Okay, to get it first. So we have actually successfully concatenated our df1. Sorry, so we have successfully concatenated our numerical and categorical columns. All right. So the next thing we have to do now is we have to go to our model building. All right. Now to go to our model building, we actually have to, so the next thing we have to do right now is to encode our numeric. So the next thing we have to do right now is to encode our categorical columns. Okay. So because in machine learning model, it does in building a model, we don't make use of categorical columns. We only make use of numbers, which are our numerical columns. So what we have to do now is we have to go ahead and encode our categorical columns, okay, so they can actually be turned into numerical columns. All right, now to do that we have to use our encoder. For this project we are going to be using our label encoder. Okay, so you can use your label encoder, you can use your one hot encoder. So we go ahead and say encoding the categorical columns. Okay, so for our encoding, we have to import, okay, our label encoder. So we say from sklearn dot pre-processing imports label encoder. Okay, I hope that's correct. Now I think just encoder. Okay, now the first thing we have to do is we have to initialize the label encoder. Okay, so let's say initializing the label encoder. All right, so this will be, let's just call this label underscore encoder. Okay, is equals to label encoder. Okay, So we have successfully initialized our label encoder. So this is the second step when trying to encode your data. Okay. So the next thing we have to do is we have to encode. So you can actually do this together at once, but I don't really like doing it at once. I like encoding each columns, okay? Especially in a situation where I don't have much columns, okay? I just like writing the codes differently, but you can always write the codes at once, all right? So let's say encode travel again, column, okay, which is also our targets, remember. So to do that, what we have to do is df1, okay, one, okay. So to do that, what we have to do is df1, so travel again, which is the column we are trying to encode, okay. Then the next thing we have to do is it should be equals to label encode that dot fit, okay, underscore transform. So remember that right here we are actually encoding this. This is what, remember that we already initialized it, okay? So this is actually the variable we are actually fitting this encoding into, all right? Okay, let's fit on the transform. And so this is the F1. And what are we encoding? Which is travel again, okay? Then we just have to go ahead and close this. Okay, so we do similar thing for the room type. All right, remember we have two categorical columns, so we actually have to do similar thing, okay, for the room type. All right, so to do that, let's say encode room type. Okay, so we do similar thing, which will be equals to the f1. Okay, then we say travel, sorry, room type underscore type is equals to label underscore encoder, sorry, encoder, okay, dot fit underscore transform, then open a bracket, df1, then room underscore type. So before we go ahead and run this, there's something I really like doing. Always like calling my data frame to see, okay, this is going too far. I'm trying to create this right here. So just that cells here. So I want to move this up to keep going down. So there's something I like doing. So let's just go here and copy this. All right. Copy this and cancel the cdf dot columns. Then let's run this just to be sure we are getting the spellings of the columns correctly. Okay. So I would just like to go here and copy this and paste it. So just to be sure we are getting their spellings correctly. To avoid any mistakes. So travel again, copy this here and let's put it here and let's put it here. Okay, so I think That's what we have successfully done this. So the next thing we have to do is go ahead and print our results. So to do that, we can simply say, so to do that, we can simply say showing our results, showing results. So this can actually give us prints, okay? df df dot head. So this is it. So let's go ahead and run this and see what we got. Okay, perhaps you forgot a comma in code. So for room type. So let's check where we are missing it out. Transform. So where is the comma missing out? Label encoder dot fits. Okay. Dot fits underscore transform. This is the one type. So it wasn't a comma actually. We forgot to close this. Say unmatched. Matched. So you know what? Let's just go here and copy this and then edit it. So let's go here and copy the room type since that is giving us a problem. Okay, now let's run this and see. Still showing us unmatched. So, okay, this is where the problem is from. Alright, so let's df1 dot head. Okay, think we supposed to add one here again. So let's run this. What's happening? The F1 dot head, F1 dot head. It's correct. So why is this saying unmatched? Okay, let's just say the F1 dot head. Let's run this. Okay, so let's go down and check if we have successfully encoded our. Okay, so this is done. So as you can see, we have successfully encoded our room type and travel again. Okay. Now for room type, remember that we have about three room types. Okay. So it has been encoded to 0, 1, 2, and 3. 0, 1, 2, and 3. So we have about four room types. So it has been encoded to 0, 1, 2, and 3. While travel again, which is yes or no, has been encoded to 0 and 1. Okay. Now, the next thing we actually have to go ahead to do is feature selection, sorry. So we have to go ahead and do our feature selection. Okay, so we have to select our targets and our where we have to, where we have to select our X and our Y. All right. So let's just turn this to a markdown and run this. Okay. So we have to select our independent features, which is our X. So to do that, we just say X is equals to df dot drop. What are we dropping? We are dropping our we are dropping our dependent features, which is our travel again. Okay, columns is equals to travel underscore again. Okay, so this should be axis is equals to 1, which stands for columns. Sorry, equals to 1, equals to 1. So So we just go ahead and run this. Okay. So the next thing we have to do is assign y to travel again, okay, which is our dependent variable. Dependent variable y is equals to hey, think we actually made a mistake here. We altered df instead of df1, all right, which was already encoded. Now, if we make use of this now, it is going to actually flop our machine because remember that in df, the categorical columns have not been encoded. Okay, so we just have to go ahead and rerun this. So this is done now. Df1 assign it to travel again. Let's go. So let's run this. All right. Now the next thing I want us to do is let's do value counts for y. So we actually know how many one and how many zero we have. So value counts y. And remember that to do value counts, we use the method dot underscore value counts. Okay. So let's say y dot value counts. So now let's go ahead and run this. So as you can see, we have a total of 532 and 518. Okay. What is the major reason for doing this? In a situation whereby in one we have maybe 100, and here we now have 518, it simply means that our data is imbalanced. Now we actually have to go ahead and balance our data using maybe smooth analysis. But in this situation now, the differences between 1 and 0 is not much. So we can go ahead and build our model. But in a situation where this is maybe 15 and this is 532, then we actually have to perform smooth analysis to actually make up, okay, maybe using synthetic data to make up for 0, okay, so our model will not be biased. So now, since this is perfect, we can go ahead now. So the next thing we have to do is splitting our data sets into test and train. Test, train. Now, when we talk about test train, splitting our data set into test and train, okay? Now, the test data, okay, is actually the set of data we use to test our model after training it, right? While the train data is actually the data that is actually used to train the model. Now, please note that the test data should be maybe 20% or 10% or 30% of the entire data set. Okay, so don't make a mistake to apportion them equally, maybe 50% for training and 50% and 50% for testing. Okay, that is not proper, that's not right. Okay, so you apportion about 30% or 20% for testing, and the remaining 70% or 80% should go for training. So to do that, let's do that together. So that should be from sklearn, okay, sklearn dot model from correct underscore selection imports train train, okay, test splits, okay. So we have actually, this is actually the model we so this is actually how we can actually train. So this is how we can actually so we have actually successfully so we have successfully imported our train splits now. So what we have to do is let's go ahead and the data, split the data, let's say data sets into training and testing. Okay, now to do that, what we do is we say x underscore train, x underscore tests, y underscore train, y underscore test. Okay, this should be equals to, so to do that, we say x underscore test, x underscore train, y underscore test, y underscore train equals to train underscore tests underscore split, okay, which is this here, which is this here, okay. Or to make it to make sure we don't make any mistake, we can simply copy and paste it, okay. So this would give us, we open a bracket and say x, y, tests size. Test size is simply how many percentage you want to apportion for testing, okay? So for the course of this, so remember I told you that it can be 30%, it can be 10%, it can be 20%, okay? But for this, we are going to make use of, let's make use of 20%, okay? 20%. So random states is always 42, okay? So the next thing we actually have to do now is let's display this now. Let's show our results. Showing results. Okay. Let's say prints. So you know these F statements, okay, used for writing statements. So we can simply just copy this and x underscore time dot show. So we can simply just copy this and do the same for the rest. So we change this to white test. Test. Okay, shape. White test shape. And this one is also test shape. So we also copy this here and do the same for y. This is y. This is y. Okay. Then we do the same here. This is y. This is y. So now let's go ahead and run this and see what we have. Closing parenthesis f. So let's just copy this here and take it to our friend and ask what is wrong with the code. Okay, so we just ask what is wrong with the code. For that to open up, thank you. Please check and see what is wrong with my code. So let's just go ahead and paste and put it on. It's two-sided couple of issues with the code. refresh. Copy, copy. See, I can still see what is wrong. I think my eye is getting- But however, let's just go ahead and copy this and paste it. Okay, so let's just paste this there. So let's just paste this here. So let's go ahead and run this again. Okay, X train is not defined. X train is not defined. Strain is not defined. Okay, so this is where the error is coming from. So let's go ahead and run this again. Oh, so we figured that out again. We are always doing this. So as you can see, this is our shape, okay? The shape for our S train, the shape for our S test, the shape for our Y train, the shape for our Y test. So the next thing we have to do is to scale this, okay? Now to scale this, we have to scale it using our min max scaler, all right? So let's go ahead and say scaling the data using min max scaler. So the first thing we have to do, like always, is import min max scaler, min max scaler. Okay. So to do that, we say from sklen again dot preprocessing, pre pre preprocessing imports imports min max scale. Okay, so after importing our min max scaler, just like we did with our label encoding, we have to initialize it. Initializing min max scaler. So let's declare a variable and let's call it min max scaler. So let's just call it scaler then. Is equals to min max scaler. Okay, I think that's it. No, I think that's it. The next thing we have to do is fit it into our training data. Okay, we have to fit it into our training data. Okay, so the next thing we have to do is x underscore train underscore scaled is equals to scalar, which is our variable dot fit underscore transform. Okay, underscore transform. Okay, this is x underscore train. Okay, then we close this. All right. So the next thing we have to do is we also have to do that for our tests. Okay, so you do skin dot test underscore scaled is equals to scalar dot fit underscore transform. It transform. Okay, then x test. So x underscore test. Okay, so the next thing we actually have to do is let's display or show results. Show results. Okay, of the scaled data shape. Okay, now to do that, we just have to print, just have to do the similar thing we did here. All right. Okay, similar thing we did here. So what we just have to do is print, just so we do not encounter the same error. Again, scaled, sorry, let's scaled, what's happening? Scaled train features. Features shape. So this will be curly brackets, okay? And we say x train underscore scaled dot shape dot shape. Okay, curly brackets. Okay, then so we do the similar thing for X text. Okay, so we do print F. Okay, scaled text features shape. Then we do curly brackets X underscore text. Okay, underscore scale dot shape curly brackets curly brackets. Okay. Okay, so I think that's all. So let's go ahead and run this and see if it works. Processing from SQL. Okay, dots, please. Let's run this. All right, so as you can see, we have successfully scaled our data. All right, so the next thing we have to do now is model selection. So let's go ahead and select our model. So please note that this is a classification supervised machine learning task where we have our targets defined. So let's go ahead and mark this down and run it. Let's run this here, please. So now the model we are going to be using are, so we'll be using logistic regression. Then we'll be using support vector matching. Then we also use random forest. I think that's what it's called. Now, the next thing we have to do is let's import our libraries, okay, for our model. Importing libraries for model training. Is so it is advisable to use 2 or 3 algorithms in order to see the algorithm that the model is actually performing better on, and in order for us to know which algorithm is our baseline model or algorithm. So to do that, the first thing we have to import is logistic regression. All right. So to import that, we say from sklearn dot linear underscore model imports logistic regression. So the second one is from sklearn dot metric. Okay, no. S from sklearn dot SVM, I guess. Import SVC, just hold this correct. Then from sklearn dot and symbol, I guess symbol import random first. So there are other things we need to import, okay, our evaluation matrix for evaluating our model. So let's come here and say importing evaluation metrics for evaluating model. So to do that, we say from sklearn dot metrics imports um classification. Just hope this is correct. You can always check it up. Confusion. So one thing you need to know is that you cannot know all the codes at once. Okay. So sometimes you make mistake. Don't beat yourself up for that. You can always look it up. Okay. The more you keep working with it, the more you gain mastery of it. All right. Here you see underscore score. So we can always check this up, even if we actually make a mistake. Then from sklearn dot from sklearn, what is what I want to import? Let's import matrix. Okay. The, we also need to import accuracy, precision, and also to do that, let's say from skline dot matrix import accuracy, it's how to spelling accuracy. So I think that is underscore score. Put accuracy underscore score. Okay, so let's check this. I think this there should be this here. Should be this here. I don't think should there? No, no, I don't think so. So let's just run this and see if we get an error. Okay, so you see we have an error. So they say cannot import name random forest from sklearn. So why? Why? Let's check. So you know, let's just take this to our friend and say correct this code. Correct this code. Write this code. Let it do thing. Just from sklearn random forest. Changed. Okay, change from sklearn assemble. Import random forest from sklearn.assemble. Import random forest classifier. Okay. All right. That's perfect. Forest classified. Just deal with this. Let's just copy this and let's run this. See, giving us invalid syntax again. Okay, just go ahead and just copy this for our life easier. Let's just run this. So this is done. This is perfect. So the next thing we actually have to do is we have to go ahead and start training our model using our various algorithms. All right. So let's say training model. Let's run this. So the first model we are going to be training, the first algorithm we are going to be training our model on is logistic regression. Logistic regression. So to do that, the first thing we have to do is, first of all, we have to initialize this model, okay, by declaring a variable. So let's call this log model, which is logistic regression, is equals to logistic regression. Logistic regression. So this is has been initialized. So we now have to fit the model on the data using dot fit. So this will be log underscore model dot fit. So remember we are fitting it into our training data and not our test data. Okay. And remember that we scaled this data. So we are fitting it into our trained scaled data. All right. Scaled. Then we fit it also into our Y train. Okay. So the next thing we have to do is we have to make predictions now. Make predictions. Okay. Let's predict. So we have to say log underscore predict. Let's say predicts. Can I just use predict here? Let's say this should be equals to, okay, should be equals to so this will now be equals to the fitted model, which is log underscore model. okay, dot predict. So we are predicting on the fitted model, all right? So this will be x text, okay, and x text underscore scaled, okay. Now let's go ahead and run this. Okay, that worked. All right. So now the next thing we have to do is let's check for accuracy. Checking for accuracy. Say accuracy. Okay. This will be equals to accuracy underscore score. Accuracy underscore score. Okay. Y underscore tests. Y underscore text. So remember, we can always look this up if we encounter any error with our codes. All right. So underscore law underscore credits. Okay. So let's check for results. Okay. So we also have to use F the print format here. So let's say F say okay the accuracy of the logistic regression regression model is. So accuracy, we see, okay, how do we want this to appear? So the percentage in which it should appear is .2f. Okay, let's make use of .2f then. .2f percent. Right. Now let's go ahead and run this and see what we have. Okay, ever unterminated string in line. We see currency on the string. Okay, I think this should be the problem. The string, so it should. Okay, so let's go ahead and run it. Whoa! So we did it. So as you can see, our accuracy is 94.40%. Okay, our accuracy for this is 94.40%, which is not bad, which is okay. So the next thing we should actually work on is support vector machine. Support vector machine. Let's mark this down and let's run it. Okay, so just the same thing we did while trading in with our logistic regression. So that's the same thing we have to do here. So we just have to say the first thing we have to do is initialize it. Initialize, yeah, that was correct. So to initialize it, we can just say svm underscore model is equals to logistic, no, support vector machine, please. So equals to svc, which is support vector classifier. Then the next thing we have to do is fit it. Fit the model to the data set. To the data set. Okay. So to do that, let's declare a variable. Let's call it let's call it okay. So to do that, we just have to copy this to make it faster and dot fit. Let's move this up a bit. Now let's take it down again. Dot fit underscore, okay, dot fit, okay. Then x underscore train underscore scaled. Then y underscore train So the next thing we have to do is make prediction. Make prediction. All right. So to do that, we declare variable. Let's call it svm underscore predicts is equals to svm underscore model dot predicts dot predicts x underscore test underscore scaled. Okay, let's go ahead and run this then. Okay, so now let's check for accuracy. Checking for accuracy. So this should be equals to accuracy is equals to, let's just say accuracy underscore svm is equals to accuracy underscore text underscore score. Okay, the y underscore test y underscore text, then svm underscore predicts. Okay, so let's check results. So check results, just worry. So to do that, let's just go to make this faster. Let's just copy this from this. Let's paste it here. So let's say for support vector classifier model. So let's go ahead and run this. So as you can see, we have 94.40 to 94.40. Okay, this will show of what we did. So SVM model is equals to SVC. Okay, then fitting SVM model dot fits x train scaled y train make prediction SVM predict is equals to SVM model dot predicts s test underscore scale. Let's run this again and run this again. Okay, so that's it. So let's do this for random forests. Let's do this for random forests. So the same thing, we initialize there. So let's declare, let's say random underscore model is equals to random forest classifier. Yeah. So we fit it then to model random underscore model dot fit x underscore train scaled y train, then we'll predicts random underscore predicts is equals to random underscore model dot predicts dot predicts x tests x underscore tests underscore skilled. Close this, then results. So let's just calculate accuracy. Accuracy underscore one, accuracy underscore one So I'm done this call. So accuracy underscore run is equals to random underscore model dot predicts. Okay, so which is x tests scaled. So tests underscore scaled. Okay. Before then, I want us to go back to this and recheck this. So checking for accuracy, SVC, should be SVC model. Okay. No, but there should be a mistake here. SVC sim model. So sim model dot predicts. Sim model dot predicts. So let's go ahead and print this. Okay. So let's print accuracy. Accuracy. Because accuracy underscore one is equals to accuracy underscore score y underscore tests random underscore predicts. Okay, underscore predicts. Okay, so let's just copy this here. So let's print this. So we have actually trained our model using our train algorithms and also calculated our accuracy. So the next thing I want us to do now is to evaluate this model by calculating our precision, our recall, and our F1, all right, our F1 score. And for each of these algorithms, we are also going to plot our confusion matrix, okay, for each of it, all right. So to do that, what we have to do is this. I've already written this code because it's a very, very long code. So all I have to do is copy it here, all right. So let's just go ahead and run this, okay, and watch it work on it. So as you can see, we have actually successfully calculated our precision, okay, our precision. This is our precision for logistic regression. Okay, this is our recall and our F1. All right. So the same thing for SVM and the same thing for random forest. So this is also our confusion matrix. Okay. Now the next thing I want us to do is feature engineering. Okay. Feature engineering. So we are going to do our feature engineering using our random forests. Okay. So let's turn this to Markdown and go ahead and run this. Okay. So this is also, let's go ahead and run this. So this is also a long code, okay? So I will just go ahead and copy it, okay? I'll- so this is also a long code. So I'll just go ahead and write it out to make this faster and paste it. So this is the code we are going to make use of, okay? So for the first thing we did was just like we have always do is actually to initialize, okay? Initialize this model to create our classifier objects, okay? Then we'll fit it, okay, into our training data set, okay? Then we now get the feature importance from the trait classifier, okay? Then we display the feature importance alongside features name. So let's just go ahead and run this. Okay, so as we can see now, we have successfully done our feature engineering using our random forest. Now, the thing you should actually notice that here is that the total customer satisfaction has the highest importance, feature importance, okay, at 0.40. The customer satisfaction average comes second, okay, and the total cost comes at 0.07, okay. So we are actually going to use the most important features, okay, to train our model, all right. But before that, I would like us to actually plot this, okay, so we can actually see a diagram representative of this feature importance, okay. So to do that, we are going to make use of the code. This is also a long code, so I'll just go ahead and copy it and paste it to actually make the video faster. So this is the code we would be using, okay. So let's just go ahead and run this. So as we can see, we have successfully made a diagram of our feature importance, okay? So from this now, it's actually very visible, okay, that the two major columns, okay, that are actually affecting our model, okay, contributing to our model is the total customer satisfaction and the customer satisfaction average, okay? Now, what we have to do is we have to train our model. We have to retrain our model on our feature importance columns. All right. Now, to do that, what we have to do is let's say X. What happened? So let's just run this again. Okay. So to do that, let's say X dot. So let's say X underscore train dot columns. Now let's run this. Now we are just trying to visualize the columns in our X train. Okay. So the next thing we have to do is to resplit our data into test and train. All right. So to do that, we say we splitting data into training and testing. Okay. Using the three major feature importance. Okay. So the first thing we have to do is list the top features. Okay. Based on our feature engineering. So as you can see that the three major features is actually the total customer satisfaction average, and total total cost. Okay. Total satisfaction average and total cost. All right. So now what we have to do is we just have to go ahead here and say X top features, X underscore top underscore features. Okay. Okay, now let's just call this top features instead. Top features will be equals to our three features. Okay. So that would be customer satisfaction. Just copy this to avoid mistakes. Customer satisfaction. Okay. Then the next one would be this customer satisfaction, then total customer satisfaction. Then the next one will be our total cost. So that will be the next one. So this is our total cost. Okay. Then we'll just paste it here. Okay. Then we'll close this. Okay. So this is our up feature importance. All right. So the next thing we have to do now is let's go ahead and select the features and data. So let's say x top underscore features is equals to x, the variable we declared, which is our top features. Then we'll close this. Then we can go ahead and split data using our top features. Okay, just the way we did with our first data sets. All right, so this will be x underscore train, comma x underscore test, y underscore train, y underscore train, comma y underscore test, comma is equals to train tests. Split, all right, 10 test splits, which is equals to our top features, x underscore top underscore features. Okay, this equals to y. Okay, then this will be equals to our test size. So we can still use 20 here. Random is always 24. Random underscore state equals to 42. Then story. So let's just go ahead and run this and see if it is correct. Invalid. Okay, this is 0.20, 0.2, 0.02, 0. Okay, so X-top feature is not defined. X-top features. Okay, this will be features, not feature. Then I think that is all. So let's just go ahead and run it again and see what we have. Okay. So this is should be 0.2, please. Just was checking. Okay, so we have successfully done that. All right. So the next thing we have to do now is to retrain this model. All right. So the next thing we have to do is to retrain this model, okay? So usually we retrain the model using our baseline model. But when we go and check now, we found out that the accuracy for all the models we trained the accuracy for all the algorithms we use in training our model is actually the same. So we just go ahead and select whichever algorithm we have since any can stand as a baseline model, okay, because they have equal accuracy. All right. But in a situation whereby we have a model or an algorithm with a higher accuracy, that will be our baseline model, and that is the algorithm we use to retrain our model. All right. So what we have to do now is retrain. We can just select random forest, just like before. The first thing we do is initializing the random forest model. Random forest model. So the next thing we do is random underscore forest underscore model is equals to random forest classifier, random random forest classifier. All right. So the next thing we have to do is to fit the model. Okay. So this is the random underscore random underscore model dot fit. Let's see what I did here. So this will be random forests underscore model dot fit. Okay. Then x train underscore train, y underscore train, close this. Then we make prediction, have to make prediction. So this will be random forest underscore prediction. So this will be equals to random underscore forests underscore model dot predict x test. Okay. So the next thing we have to do is calculate accuracy. Calculate accuracy. Okay. So to calculate accuracy, what we have to do is random underscore forest underscore accuracy. This will be equals to accuracy underscore score. Okay. Then y underscore test random underscore forest underscore prediction. Okay, underscore prediction. Okay. Then just like we did the last time, so we can just go and copy this to make this faster. So let's just come here and okay, let's just copy this first. Then we can just come up here and paste it. Okay, which is also for random forest. Let's just say retrain. So let's just go ahead and run this and see. So as you can see, it's giving us 94.76%. Okay, now let's go up. Okay, as you can see, it gave us 94 94.40%, okay, before 94.40%, okay. But now, after our feature engineering and selection of our feature importance, we are getting an accuracy of 94.76%, which is actually an increased accuracy. Okay, so now we have come to the end of the first machine learning building class. So the next thing we are going to do, this is just a bonus. So this is just a bonus training. I will show you how to save your baseline model in a Pico file. All right. So let's say saving baseline model in a Pico file. In a Pico file. Now, our baseline model is random forest model, which gave us an accuracy of 94.76%. Okay, so the random forest model is actually our baseline model. Now, the first thing we have to do to save this in a Pico file is to import Pico. Okay, I'm so excited that we have gotten to the end of this first machine learning building class. So import Pico. So the next thing we have to do is Pico underscore out is equals to open, okay, then classifier. So in the video when we are doing our deployment, okay, so this is actually the model we are going to deploy to our streamlets and to our flags, okay, dot pkl, okay, that should be mode is equals to wp, I guess, wp, okay, then it should be in. Then we have to close this. Then we dump it there. We dump it in the Pico file, which is Pico dump random underscore forest random. Let's just copy this and paste to avoid any mistakes. Random forest underscore model. So just here, Pico out. Pico out. Okay. Then we close it. Pico underscore out dot close. Okay, so let's go ahead and run this. So we have actually successfully saved this baseline model. Okay, now let me show you where you find the baseline model after saving it. So you go to your PC, you go to your user here. So let's look for our Pico, our classifier. That's what we use in saving it. Classifier. Okay, so as you can see, this is our classifier. Okay, 11th, 1st, 2025. Okay, so this was when we saved our baseline model. Thank you for coming to the end of the class.